Ok, bentornati. Allora, dopo la pausa pomeridiana, ricominciamo adesso con il nostro ospite internazionale, appunto Chris McKay, che ci illustra le analogie tra gli orologi di Pietro Mei e la Coeva Produzione Inglese. Dal momento che la connessione ci assiste oggi, quindi lui è riuscito ad essere qui con noi, quindi gli chiederò di introdurre il suo contributo e poi eccoci godremo insieme comunque con le riflessioni, i parallelismi che ha preparato per noi. So Chris, thank you for being here once again, and so we are very thrilled about, before Sauro has gone very in depth, on the mechanisms, and so now we are very curious to close this gap, with the English clocks and the Montecarotto ones. So I just translate very quick. Dicevo appunto che siamo molto emozionati essendo andati così in dentro, essendo così entusiasmati, no? Avendo conosciuto più in profondità i meccanismi della Scuola Orologiaia Montecarottese, ora c'è una certa attesa, ecco, di capire veramente quali parallelismi e quali legami così forti ci siano tra gli orologi inglesi e la produzione montecarottese. So, Chris.
Hello, everyone. Thank you so much for inviting me to participate in this conference. Unfortunately, I can't be with you. I live in England, and we all know the current situation, so none of us can get together. So it's great to be here virtually, but it's a pity we can't meet personally, because that makes all the difference. This is a talk about turret clocks in England, and those are ones that are very, very similar to those in your area. And what I've done is select a few clocks, and I'll talk about the features of these in order that you can see exactly what I have in mind. A little bit about me first. Well, it was when I was 11 years old, I became interested in turret clocks. And 60 years later, I'm still interested in turret clocks. And I've migrated from the very technical side of horology to a much wider side, including the social history as well, which now I'm finding almost more interesting than the technology. Here is a map of England. This shows you where the major clocks are that I'm going to be talking about. And we're going to start down in the middle of the south of England at Stourton. And then we turn to Boston, which is Lincolnshire, up near the Wash on the eastern side of the country. Then we go down to Staines, which is west of London. And we end up with Auckborough and Winterton. This gives you just an idea of where these clocks are. And there are no reason to have any geographic connections between them. We start off with Henry Ward of Blandford. Blandford is a little town in Dorset. It's about 15 miles from the south coast and is a market town. Henry Ward lived there, and he was only 39 years old when he died. He was certainly a very interesting maker, and he came up with some interesting technological advances for which he got various prizes. Here is a list of what he was awarded. The Society of Arts gave awards to people for all sorts of things, and Henry Ward received prizes for these things listed here. First, there was a regulator clock, a compensation pendulum to compensate for different temperatures, a most curious and striking mechanism which used the pendulum as an energy source to operate a bell. Of course, this was for a domestic clock. An equation work that would display the difference between mean time and solar time. And finally, he got a prize for some semaphore shutters. There was a visual telegraph system that ran from London to Plymouth using shutters. And in that way, the Admiralty in London could signal Plymouth and get an answer back. And this started in the late 18th century. He was a truly amazing man. We only know of one turret clock that Henry Ward made, and this is here in Stourton in Wiltshire. Stourton is a very pretty village which is about 30 miles to the west of Salisbury. There is a very large house nearby, and this is probably what we would call an estate clock, an estate church, where the upkeep was heavily dependent on the local lord of the manor. He put a clock in 1804, and I'm pleased to say we have some pictures of this, which appeared at a turret clock meeting the Antiquarian Horological Society had some years ago. Here is the clock. This is the front view. Quite a small clock, and you notice straight away that there is on the right hand side a very long small barrel and a very, very large great wheel. This gears directly into the escape wheel. You can see the pins of that poking out, just hiding behind the front frame. And on the top is a fly. It's a vertical fly, and that is driven by a worm. This is the back of the clock now. And what you see here is the vertical fly. It's very difficult to see the worm, I'm afraid. I don't have a good photograph of that. But on the right hand side you see the back of the striking train great wheel. On this are 78 pins, so that this great wheel rotates once in 12 hours. There is a striking lever, a bell hammer lever, that is raised by these pins. As these are so close together, you can imagine the technical difficulty in getting a clock like this exactly adjusted and working properly. This is just a different view of the striking train. What you see here on the great wheel is the teeth are at a slight angle. Well, this is to engage with the worm, which you can just about see on the extreme left hand side of the great wheel. The release of the striking and the locking is a little bit on the complex side, and not surprisingly it has given troubles in the past. You can see on this side of the great wheel there are various pins, and these are placed in order to give the appropriate run for the hour to be struck. So the great wheel also works as a count wheel to have the number of hours to be sounded. In England we never have the hour repeated, which is a common feature in continental clocks. So the hour strikes and that's it. Here's the setting dial of the clock. This is for setting the time on the dial outside. The minute hand is missing at the moment, but it's rather interesting that Henry Ward never signed this clock, which is a slightly peculiar thing, because almost all turret clocks in this period are signed by the maker and dated as well. Moving to the going train, we can see here the pendulum suspended from a bracket on the clock. You can see the pins on the back of the escape wheel, and in fact there's something like 120 of these. The pallets are placed on the pendulum, so there is no crutch. Here you can see the view of the pallets behind, in front of the escape wheel. There's a little window in it so you can check the depth and operation. This is typical of what a good maker will provide on a good clock. We move on now to William Wynne. He was born in Farnham and he moved to London. He made turret clocks. We know about 5 or 6 of these. He got prizes from the Society of Arts, and I have a watch movement signed William Wynne, and we also know of a few long case clocks signed William Wynne. Whether he actually made the clock himself, or turret clocks himself, we don't know, but almost certainly he would have had them made for him, but to his particular specification. Like Henry Ward of Blandford, William Wynne won various Society of Arts prizes. First of all, in 1817, he had a prize for a regulator clock. We'll see some pictures of this later on. This was a peculiar thing, and it had roller pallets, which is the similarity between this clock and the clocks that you have in Montecarotto. In 1822, he designed some turret clock hammers, and he got a prize for those as well. Unfortunately, we don't know any example of his regulator clock, and the few examples of turret clock hammers are now gone. Boston Stump. That's the nickname given to this wonderful tower in Boston in Lincolnshire. In 1826, William Wynne installed a clock there. Fortunately, this was well documented in a series of letters in a thing called the Mechanics magazine, where he had an ongoing argument with another clockmaker. Let's now have a look at the movement. Before we look at any of William Wynne's turret clocks, we need to have a quick look at his regulator. Here's a drawing of the clock for which he had a prize. A fairly standard sort of regulator, but interesting. He used friction wheels to support all the pivots, and the escapement is there detailed on the left hand side. Let's have a look at that in a bit more detail. The pallets have pivoted pieces at the end. If you look on the right hand side, there is half a cylinder which is currently rolling over a tip of a tooth on the escape wheel. The weight on the right hand side that sticks out horizontally is a counterbalance. So when the pressure is relieved, that drops down vertically, and that then allows the escape wheel to pass. The reason that we have half a circle is just for that reason. You can see on the other side that the pallet is fully engaged. Here now is the movement at St Botolph's Boston Stump in Lincolnshire. So very solid 3-train movement. Sometime about the 1870s, the escapement was removed and replaced with a gravity escapement by a company called Gillett and Johnston. This picture was taken in the early 1930s. In 1932, the clock was removed and replaced with a synchronous electric clock. I believe this is the first synchronous electric clock for a turret clock in England. A nice little feature about this picture, I like the clockmaker's candle up on the right hand side. The clock movement went on display in the church, and then sometime it went missing. It is believed that it was taken for scrap metal during the Second World War effort. Here is another clock by William Wynne. This is in Staines in Middlesex, and it's about 15 miles from London. We have here a 2-train clock, and we have some new pallets on it. One of the problems with Wynne's escapement is that the pivoted pallets had very small pivots, and in a church clock environment, a dusty tower, damp, condensation, perhaps drafts and things, it was prone to getting jammed up and prone to wear. If you look at the going train on the right hand side, you will see at the very top there's an empty hole in the frame. This is where the original bushes were for wind's escapement. Today, this has a conventional deadbeat escapement. And here we see that Wynne has, in 1829, installed his clock. And at the bottom, 1893 to 4, Mr. Kent has improved the clock. Well, he's made it work, I expect, by taking Wynne's escapement out and inserting his escapement, which is a standard deadbeat. A little bit more detail of the escapement, and the empty hole is just out of view on the top of the picture. Just a complete looking at William Wynne. He had a prize for a compensation pendulum, and what he could do was suspend the pendulum from the top, which had bars of steel and zinc, and by adjusting the points where they were clamped, he could essentially effect compensation that was adjustable. One of the problems was you never knew exactly what the expansion coefficient was for your metals. You also have here a front view of his regulator clock. The other thing I mentioned was William Wynne's turret clock hammers. Most turret clock hammers have got a spring which keeps the hammerhead off the bell and just allows the hammerhead to hit the bell, but then holds it off so that the bell can ring properly. William Wynne decided that this was not a good idea, and he just had a hammerhead that hit the bell, and when the head hit the bell, it rebounded off, and on the left hand side you can see a ratchet and click mechanism that held the hammerhead well off the clock. On the right hand side you can see a section of his proposed bearings. These were completely enclosed, so no dirt could get in. Quite a complex arrangement, but incredibly good, I'm sure. We pass now to James Haddison, number 4 of Hull. He lived in Hull. He was a turret clock maker. He didn't make domestic clocks or watches or anything like that. We know of about 20 clocks that he made. He too received awards from the Society of Arts. In 1831 he had a prize for his clock escapement and an expanding fly. The expanding fly incidentally had blades that expanded to regulate the speed of striking. This is Auckborough Church. James Haddison installed a clock there in 1826. Here is the drawing of the Society of Arts prize that he received. The escapement is essentially a gravity escapement. Harrison calls it a detached escapement. On the picture on the right hand side you can see 2 pallets, quite complex things, which are hinged at the points marked G and F. On the extreme right hand pallet there is a weight at the end, and essentially this is what impulses the pendulum. At C and B there are little rollers that provide for less friction. Here is the clock at Auckborough now, and it has the escapement virtually exactly as James describes in his account. He had an account in not only the Society of Arts transactions, but in a journal called the Mechanics magazine that we shall meet a little bit later. Here's the escape wheel. You can see top right hand corner on the escape wheel one of the pallets with one of the rollers. The clock is quite interesting. you see on the lower right a cast iron grate wheel. 1826, I think this is the first use of cast iron for a clock wheel in England. There's another view of the escapement and grey wheel. You can see the roller on the left-hand side. That's the exit pallet. Robinson and Beacock. Robinson was a clockmaker and Beacock were a blacksmith, and they lived in a town called Winterton, which is probably 5 or 6 miles from Auckborough. Almost certainly this clock was designed by the father of James IV, who we call James Harrison number 3. And it was probably done to test out Wynne's escapement. It's a long story, but there was a lot of correspondence in the Mechanics magazine between Wynne and James III. Just a little bit of history about the Harrisons. There were 4 James Harrisons. James Harrison number 1 was the brother of the famous John Harrison, who designed a clock to find longitude. He had a son we call James II. There was James Harrison III, who was a bell founder and also involved in church clocks, and his son James Harrison IV, who made turret clocks. Let's now look at the Winterton clock. Winterton is in the north of Lincolnshire, and here is the church. The dial is probably an early 20th century edition. The clock is quite fascinating. The design is very, very much what James Harrison IV would use, and there are certain features on it that are identical to what James IV would use. However, the workmanship in this and certain details indicate that it is not the work of James Harrison IV. But it's the escapement that's the interesting thing. Now you have a person in the view, you can see just how large that escapement is. This is the exit pallet here. You can see the tooth just pressing on a roller. And what happens is that when it escapes, that whole pallet frame is hinged. And it allows the escape wheel to pass. Sorry, this picture's a bit dark, but here is the entry pallet, and which is not engaged. You can see the pivot of that little pivoted frame about sort of 2/3 of the way up the hinge pallet on the right. This clock in fact does produce really quite good time and behaves well. I'm pretty sure that it was James III who designed this clock. He lived only a few miles away in a small village, and so was in easy communication and was able to supervise its manufacture. A rather rural piece of inscription here, 1834, Robinson and Beacock made it. Quite a nice pendulum bob with a wooden rod. So we now move to asking the question, was there a connection between England and Montecarotto? Well, first of all, the Transactions of the Society of Arts. This was a fairly formal document, and it was published annually, and it reported on all sorts of things, including all the prizes that had been awarded. Subjects covered include mechanics, agriculture, chemistry, civil engineering, shipping, all sorts of things. And this is where both Wynne's escapement appeared and Harrison's escapement appeared. This is the sort of document that learned societies throughout Europe would have wanted in their library. Could it have been seen in a library in perhaps somewhere like Ancona? Quite possible. It was an academic journal, so it was circulated in educational establishments. We turn now to the Mechanics magazine. It's published every 2 weeks, and it covered mechanics in all its aspects: steam engines, electrics, buildings, ships, etc. And Wynn's clock hammers and Harrison's escapement both appeared in this publication. The publication was aimed at practical artisans. So it's the sort of thing somebody who was using tools would want to receive. Could this have found its way to Italy? I don't know. Perhaps there's a research project there for someone. Well, that's it. I finished. I hope you found this interesting. I think I've asked questions about the possibilities of connections, which I cannot answer, and I'm sure they won't be answered, but they're food for thought, and perhaps somebody might want to look in the library in Ancona and round and about to see if there possibly is a link for these books and journals that I mentioned. Thank you again for having me. I've really enjoyed doing this presentation, and again, I'm sorry I can't meet you personally. Bye.
Grazie.
Thank you, Marissa. Thank you, Marta, for pressing all the buttons.
Thank you. Thank you, Chris.
Sorry for the technical flaws. If you want to add anything, but really, please, thank you for
no, that's fine.
And also for the stimuli for further research. So thank you for that. Ok, ringraziavo quindi, dicevo, Chris per davvero la carrellata interessantissima, assolutamente elettrizzante, e anche per i brillanti stimoli, insomma, per futuri approfondimenti di ricerca. Davvero è stato molto bello. Se alcuni hanno qualche domanda, curiosità o qualcosa da aggiungere prima del prossimo relatore. Okay, so thank you, Chris, once again. So we are heading off our last presenter. Grazie ancora, dicevo, a Chris. Passiamo ora a Giulio Gagliardini, che è l'ultimo relatore, diciamo, di questa giornata.